Math 76, lesson 96. We're going to be writing mixed numbers as percents. Again, continuing our study of how you can write the same number many different ways. Right? So when it comes to writing mixed numbers as a percent, we need to remember the same rules that we use from writing fractions as a percent. Now, the book teaches you to just multiply by 100% and then simplify your answer the same way that we would do it with a decimal. I've got a bit of a faster method, which is you just use division. My brain got stuck for a second there. Yeah, the slightly faster method is you just divide the fraction by itself. And that's one of the things that I've been saying constantly throughout the school year in class, which is that fractions are the same operation as division, right? Or as we shorthand say fractions are the same as division. The same operation as division in a fraction looks like this. If I've got the fraction 4/5, that is the same problem as 4 divided by 5, right? So if I divide 4 by 5, I'm going to have to add a decimal there, and then 5 won't go into 4. I put the decimal, but 5 will go into 48 times, gives me 40, and it cancels out. Great. So now I've turned this fraction into the decimal 0.8. Right? Now some of you may be thinking, like, Mr. Claiborne, we're supposed to turn it into a percent. Well, if you remember in the previous lesson, we learned how to turn decimals into percents. It's really difficult process. We have to move the decimal. Oh wait, it's not that hard. It's a pretty easy process. We move the decimal 2 places to the right, and now we've got a percent. So 4/5 is equal to 0.8 or 80%, right? And that would be our final answer. So we're going to be using the same process, but now we're going to do it on mixed numbers. So there's one extra step in the beginning. The one extra step is to rewrite your mixed number as an improper fraction. So I'm going to take a pretty easy example, and then we'll do a difficult example, so that way you guys can be prepared for all the problems you're going to run into. So we'll take the easy example. We've got 1 and 1/4. Right, so the new step in the beginning now is I'm going to take 1 1/4 and turn it into an improper fraction. I do that by multiplying the denominator by the whole number, then adding the numerator. So I do my math that way. 4 times 1 is 4, plus 1 is 5, and the denominator remains 5/4. Right, so now that's my fraction. That's backwards from what we just did. Now, again, I'm going to turn my fraction into a division problem. Right, this time the 5 is on the inside, 4 is on the out. Add some decimals. 4 goes into 5 one time, gives me 4. Subtract 1 left over, bring down the 0. 4 goes into 10. Oh, well, I need to put my decimal there. 2 times 10, 4 is 8. Subtract, I've got 2. Put another 0. Bring it down. 4 goes into 25 times 1.25. Then to turn this into a percent, 125% is my final answer. All right. So the steps that we're going to do here: convert to an improper fraction, divide, convert to a percent. Right? That's more or less what your book is asking you to do. They use some different methods, and you'll see that on the pages. I feel like this method is a little bit more streamlined, and it's something that gives you a little bit of a mental break from all the proportions and fractions that we've been doing in this book. So it's not that I don't value the method the book uses, it's just this is a little bit faster, and I would view this as more of an algorithmic operation as opposed to a logical operation. So now that I've said a bunch of words you don't understand or don't care about because you don't listen to the definitions in class, we can go on to the hard example, because that's what you do care about. Mr. Claiborne, how am I going to solve the hard problem that's on the test? Well, let me show you. So let's say we have 2 and 1/6. Right, this doesn't look that hard at first. It seems like it's going to be the same steps, but we're going to run into a hiccup at the end, and I'll let you know when we get there. Right. So first step, still the same. Multiply denominator by the whole number. I get 12. Then I add that to the numerator, and I get 13. The denominator remains 6. 13/6 is now my fraction. I'm going to turn it into a division problem. I put the 6 on the outside, put the 13 on the inside. I'm going to put some decimals because I think it's probably going to turn out that way. Now, 6 goes into 13 2 times. 2 times 6 is 12. Subtract. I got 1. Bring down a 0. 6 goes into 10. Oh, you put that decimal point there. 6 goes into 10 one time. 1 times 6 is 6. Subtract. I've got 4. Bring down the 0. 6 goes into 4 6 times. 6 times 6 is 36. Subtract 4. Add the 0. Bring it down. And ooh, I've got 2 problems. The first problem is I didn't keep the camera tracking the work on the page. The second problem is I've just gotten 4 twice in a row. So when I ask myself how many times will 6 go into 40, the answer is going to be 6. And then 6 times 6 will be 36, and then 40 minus 36 will be 4, and then I'll bring down a 0, and then I'll have 40, and then I'll ask myself how many times will 6 go into 40, and the loop will never end. Who remembers what we do in this situation? Well, if you remember what we do in this situation, once we get remainders that repeat, we just take this value and we write it as a fraction over our denominator. Right, so that's only if you get the numbers repeating, where you start that never-ending loop. If you start that never-ending loop, then you just take that number, write it as a fraction. 4 6 will reduce to 2/3. So now I'm going to take my decimal and I'm going to move it 2 places. 1, 2. So now it's 216 2/3. So I write 216 2/3%. All right, and that's the hard version, right? So if you get a decimal number that starts repeating infinitely, you just take the remainder, write it as a fraction, and you're done. If you have any questions, let me know on the school website, and I will see you in class.